Hello, everybody. Welcome to what will be a very busy revision class today because, of course, lots of people wanted to come because, of course, you all got your exams tomorrow. Now, I'm very much hoping that everybody's got the questions, and I will now put a link for the questions into the chat. Right, now, could somebody just talk to me just to tell me that you can hear me okay?
Yes, I can hear you.
Oh, brilliant. Great. Thank you very much. I think there are going to be so many people that we're going to have to do questions after, we won't all be able to shout out at once, I'm afraid. But I can make time for questions after I've been through a number of questions. And I'm also going to put a link for the answers to the questions because it may be that you're working ahead of me and you just want to check your answer and move on. So I'm going to put the answers in the chat as well. And it's only 7 minutes to 6, so everyone's in very good time. So who's furthest from the UK then? Anybody here? Anybody Africa? Or maybe you're not going to talk to me. You could tell me in the chat where you're from if you fancy that. I'm pretty sure that we've got some folks from Kenya. Oh, hello. Um, so what are you? 3 hours ahead in Kenya, I think. So it's 9 o'clock in the evening. Now, a few nights ago, we had somebody from India. I think they were 5 or 6 hours ahead. Bangladesh, how many hours ahead are you? Bangladesh and Pakistan. If it's 6 o'clock in the evening now, what's the time for you guys? I'm imagining it's pretty late. 11 p.m. Well, thank you very much for coming. 12 a.m., as in midnight. Crikey. So when are you when are you going to sleep? What time's your exams start tomorrow in Bangladesh? Ah, okay, so it's not till the afternoon, so that's something. Okay. Right. We've got 5 minutes to go. I'm thinking that people will suddenly start joining, or they'll suddenly start sending me messages asking me for the Zoom link. So we'll see what happens. I'm just going to be quiet for a minute and sort out some people on email.
Basically, it's like an online tutor thing, and I bought him for £15 for an hour and a
109
half.
people.
And we're going through like predicted questions. No, babes, I wish it was free. But like he's given us all these past paper things that he thinks going to come up, and he is actually good. Like I have been watching his YouTube just like recently, but it's like targeted for 7 and 8. Oh,
I am actually half good sometimes. Is that you, Barney, singing my praises?
the fuck?
Yeah.
Oh my god, I'm gonna make some friends. No, it's predicted questions for tomorrow. And like he has done well like before. Like I've seen the reviews, and apparently it does come up and stuff like that. So we're going like it's like hold on. It's grade 7 to 9, and it's an hour and a half with basically like predicted questions that he thinks are going to come up, which none of these did come up in paper one. So it's like actually a bit true. But half of these people are from India, and I don't know why they'd be doing the same exams.
Maisie. Hello, Maisie. Oh, she's muted herself. Sorry, Maisie. I didn't mean to embarrass you, but you were on not on mute. Okay, everyone, we're going to start but we'll start 2 or 3 minutes late just to give some latecomers a chance to join. But we're not going to start any later than that because I know for some of you it's very late in the evening. So everybody should have the questions, but if you don't, here's a link in the chat again. I'll just put it in a second. And also, I've put a link in the chat to the answers as well, so you can work independently rather than waiting for me to get to work out the answers. Okay, so here are the questions again, and here is a link for the answers. And if you're bored and you're just waiting for us to start, why not make a start on the questions and get ahead of me? Okay, so don't wait for me, just crack on.
Right. You right? Yeah. How are you going on?
Okay, everyone, no reason why you shouldn't make a start on these questions. Don't wait for me. You should have the questions from the email, and if you haven't got them, you'll find links in the chat. If you haven't got the questions and you can't find the link in the chat, send me a chat and I'll send you the link again. Anna, I would just mute yourself, please. Perhaps I can find you and mute you. Anna, can you mute yourself? Or is that perhaps that's not Anna? I'll mute this person.
Hello, how you doing?
Hi, very well, thanks. Questions are on the screen or in your email, I hope, everyone. And we're just making a start on them now.
All right. Quick question. Were you able to take a look at the paper one that we did for higher tier?
I have done, but today we are concentrating just on the questions which I've sent.
All right. Now, I just want to ask you, is coordinate geometry was covered or had that not been covered in paper one? Just want to
It
ask
was
that.
covered in paper one, yes.
It was covered in paper one because I heard some teachers think that that was only simultaneous, not coordinate geometry.
Well, we're not doing coordinate geometry tonight. I might be wrong,
All
and
right.
maybe it'll come up again.
Yeah, all right. But chances are it won't, most likely.
Well, I don't think so, but who
All
knows?
right.
Because they're only predictions.
Yeah, that's true.
Okay?
All right. Thanks.
All right. Okay, everybody, I'm about to make a start. I'm thinking today that essentially most of you, please, if you could remain on mute, that would be great. I am going to put the link for the answers to these questions one more time in the chat, and also a link to the questions themselves. If you want to work ahead of me, that's probably best. If you get stuck on something, it's probably best to wait until I work on that question myself. Okay. And I will try my level best to fit in some time for you to ask questions verbally at the end, okay? Or after a certain number of questions, because the trouble is there are too many people who wanted to come tonight for us all to chat at the same time. Okay. So I'm very much hoping that you've got the questions. I've just put a link in the chat and you've got the link to the answers. So if you want to check your answers without me, you can. And to be honest, I would just go ahead and make a start. And if you come I'm stuck on a question, take a first step, see if that helps you out. Otherwise, just leave it, move on, and I'll catch you up very soon. Okay. And I'm thinking, just to give everyone a chance to get started, that I'm going to be quiet for 5 minutes and let you guys make a start. Right, I'm thinking I'm going to make a start on the first couple of questions. Okay, Now, only you know how easy or difficult you find these sorts of questions. So if you find them quite straightforward, you're going to be aiming for full marks on these kind of questions. And if you find them more difficult, then you're going to be aiming to take a first step and see if that helps you take a second step and a third step. One thing's for sure, if you take a first step, you're going to start to pick up marks. Okay? Now, in this case, I've got three consecutive even numbers. Now, n could be any number at all. If I want an even number, I'm going to be dealing with 2n, because 2 times any number is even. So that is going to be my first even number. Now, three consecutive even numbers, so one even number after another. So 2n, the next even number would be 2n plus 2, and the even number after that would be 2n plus 4. So I've got there three consecutive even numbers. Now it wants me to prove that the sum of the squares of the smallest and the largest. Right, let's do that in red, shall we? The total of the squares of the smallest and the largest. So the square of the smallest plus the square of the largest. There we go, that's the red. And it wants me to prove that that equals 8 more than twice the square of the middle one. 8 more than twice the square of 2n plus 2. So 2n plus 2 squared plus 8. So that on the screen is what it's asking me to prove. Okay, what I'm going to do is I'm going to carry on with the red, carry on with the green, and I'm thinking that at the end of the day, they're both going to end up equal. Let's see what happens. 2n times 2n is 4n squared, and now I'm going to multiply out these brackets. And then my green is 2n plus 2 times 2n plus 2, and then plus 8. And I'm just going to carry on following my nose. Okay? So that's going to be 4n squared plus, multiply out this bracket, 4n squared plus 16n plus 16 equals, onto the green, 4n squared. Now I'm going to get 4n and then another 4n, so that's 8n plus 2 2's are 4 plus 8. Okay, what's going to happen next? Oh, come on, guys. Why hasn't one of you interrupted me here? Because I've set this up incorrectly. In the green here, it says 8 more than twice the square of the middle number. There you are, my early nerves paying in. So in green, we should have this, shouldn't we? 8 more than twice the square. Now it's going to make more sense. 4n squared plus 8n plus 4 plus 8. I hope that looks better. So on the red, I've got 8n squared plus 16n plus 16. And in the green, I've got, multiply out that square bracket, 8n squared plus 16n plus 8. Copy down the plus 8. Look at that. I've got in the red 8n squared plus 16n plus 16, and in the green 8n squared plus 16n plus 16, and I can breathe a sigh of relief because it worked. So that is how to go about question 1. Now, question 2 is just a question of, can you remember the method to show that, to convert a recurring decimal into a fraction? And the reason I put this in tonight is because it hasn't come up yet, and if it does come up, you can just try and remember the method. And then question 3 and 4 and 5 are some circle theorem questions, because we haven't had any circle theorems yet. Okay, I'm going to be quiet again and recover from making a mistake on the first question. And in a few minutes' time, I'll have a look at 2 and 3 and 4. Now, don't we write a conclusion statement You can write a conclusion statement. In the mark schemes, it doesn't insist upon that, as long as you've shown that one expression is equal to the other. But there's absolutely no harm in writing a conclusion statement. And thank you for the question. Okay, circle theorems, recurring decimals to fractions.
Excuse me?
Could you
Just one question.
do you think you could type your question in just because there are
All
so
right,
many people?
all right,
Okay.
sure.
I will certainly put the answer here in the chat one more time. That's no problem. I'm very happy to answer questions, but I think it's best that they're asked in the chat because then I can answer them when makes sense. Yes, you could do that, Mohammed. Yes. Now, could we please avoid chatting about anything except the questions in hand in the nicest possible way? Because I don't want us to be distracted in the short time that we've got together. Okay. Now, I'm going to lay out how to do question 2. You might just want to ignore me if you know you've done it and you've got it sorted. Okay, so please feel free to ignore me, but I'm going to lay it out here on the squares. And these are always done in the same way. Write x equals, leave yourself a bit of room, and then write down what x is and repeat those digits a few times so you can see what's going on. Now, in this question, it's 2 digits repeated, so I'm going to work out 100x. And the reason I've chosen to do that, and look how I'm writing it, the decimal point there. The reason that I've chosen to do that is because then the equal digits end up underneath each other, which is really convenient because now I'm going to do the bottom row minus the top row. So 100x minus x is just 99x. And on the right-hand side, 38 point, well, when you do this, all of those to the right-hand side are going to disappear. So 38.1 subtract 0.3 is simply 37.8. And now I'm going to divide both sides by 99. 37.8 over 99. And if you shove that in your calculator and press equals, you will get 21 over 55, which is exactly what they wanted you to get. Okay, now that will get you full marks, just as is written on the screen there. Now, the trouble is, if you multiply by different things, which you can do, you just need to make sure that whatever you multiply by has the effect of putting equal digits under equal digits. If, for example, you were to multiply by 1,000, then you will get 381.8181, and you can see how the equal digits aren't underneath each other. So you can't do the subtraction trick. If you wanted to, you could, instead of multiplying by 1,000, if you wanted to, you could multiply by 10,000. That would be okay, because if I multiply by 10,000, then how many digits is that? Wait a minute, 1, 2, 3, 4. Then you end up with an 8 here, a 1, an 8, and a 3. And then you're going to go 8, 1, 8, 1, 8, 1. And look at that. You end up with equal digits underneath each other. So you can do the subtraction trick. All right. A good rule of thumb is, well, I always test it out by multiplying by whatever I need to, and then I check that equal digits end up underneath each other. There are lots of different ways of doing it, but you cannot multiply by 1,000 in this case, because you won't get equal digits underneath each other. Okay. Ah, I'm sorry, I've just realized what somebody has said in the chat. You can do 1,000x and subtract 10x. That'll work, because then you've manipulated both the x and you've got equal digits under each other. So that'll work absolutely fine too. Okay. Okay, thank you for helpful chats. I hope everybody's okay with that. On to circle theories. Theorems. Whenever I see a circle theorem question, I always think, before I kind of start, I think, okay, what are my circle theorems and which one might apply? And in this sheet here, I've deliberately given you a relatively straightforward question, question 3. I hope that's relatively straightforward. Question 4 involves a couple of circle theorems, different to the ones in question 3. And question 5 again involves a couple circle theorems. Now, question 6 involves the intersecting chord theorem, and the chords intersect outside the circle. So there are a number of circle theorem questions for you to get your teeth into. You can definitely start the third question. Don't wait for me. You just crack on, okay? Because maybe we don't have time to talk through all the questions. So you do all the questions you've got time for. And yes, I can share the link to the question paper and the answers once again in the chat. I'll do that right now. I wonder if I pin the chat, the link, whether or not you can all get it. We'll try that in a minute. Questions? Oh, there we go. Okay, good idea to write down your theorems, or at least to think about them and then think, okay, which ones apply. Right, so let's have a think about circle theorems then. Okay, now if you want to ignore me, you can ignore me, but here are a few circle theorems for you. One of them is about coming from here. Here's a chord. So coming from this chord and then using the same chord and bouncing off, those two angles are the same. Another one is about bouncing off. Oh, that's not a very good circle. Another one is bouncing off the same chord, but here's a chord, bouncing off the chord in green like that, and then another bounce being just to the center. The angle at the center is twice the angle at the edge. Let's just use those two to start with. Oh, by the way, we can use this one as well. Angles in a semicircle. If that's a diameter, then this one is 90. Okay. Right, so there are some circle theorems reminders. All right, in a moment I'll go through those questions. Right, so one of those circle theorems is called the angles from the same chord, or angles extended from the same chord. Yeah, and you can also call it angles in the same segment are equal. That's absolutely right. That's the first one that I did. Okay, right. Question 3. We've got well, that's an isosceles triangle there, isn't it? Because both of those are radiuses. So this one is a 52, which means that the angle at the top there in the middle is 180 minus 52 minus 52. Okay, so that's the angle at the center, which is 76. And then the angle at the edge is half the angle at the center. So that is 38. Now it asks you to give reasons for your working. So the secret is at each stage to write down what you're saying or thinking. So what I did there was I did OAC. No, I didn't. I did OCA equals 52 because it equals OAC, isos triangle. And then I did AOC equals 76, 180 degrees in a triangle. And then I did ABC equals 38. And I would write the angle at the edge is half the angle at the center, or the angle at the circumference is half the angle at the center. Now I like question 4 because it uses two circle theorems. The first circle theorem that I can spot is here. Look at this. That's a diameter, right? So what I've got here is I've got an angle in the semicircle. So I'm already thinking that this angle here is 90. So I would write down ACD equals 90, brackets, angle in a semicircle is 90. Okay? That's right. Now, have a look at this. Now, they've made this tricky. Well, this one isn't so tricky. They've drawn this chord for you. So I'm thinking that we've got 28 and that one will be 28. Okay, good. So I'm okay with that so far. Now, the chord they haven't drawn for you is this one. Look, A to B. But if you draw that chord, maybe you can see that this angle 32 is equal to that angle. So that angle there is also 32. Right, now I'm kind of thinking I've found out loads. Now I'm going to look at the question, which perhaps we should have looked at first of all. Find the size of angle BDC. So what I tend to do, BDC, is I tend to mark it and then do a kind of, that's my target. Because that helps me see where I'm trying to go. Now I've marked that there. Ah, now wait a minute. Look at this. BCD is a triangle, right? It's here. It is B to C to D. That's a triangle, and that's got 180 degrees in it. And I know one of the angles is 28, another of the angles is 32 plus 90, and so therefore I could work out the third angle. Okay, so I'm going to do 180 minus 28, minus 32, minus 90. And I believe that gives you 30 degrees for your target angle. All right. So that's question 4 sorted. And we use 2 of the theorems there. Angles in the same segment are equal, and an angle in a semicircle is 90 degrees. Okay. The chord one is absolutely right. Angles in the same segment are equal. Let me just explain why that is. Don't listen to me if you don't want to, of course. If you're busy working, carry on. So, if I have a circle here, and here is the chord splits the circle into segments. So this is a segment of the circle. And these 2 angles, this green angle up here and this blue angle here, are both in the same segment. And hence it's called angles in the same segment, and those 2 angles are equal. Okay, yes, the answer is 30. When you do angles in the same segment theorem, no. When you do angles in the same segment, one of the lines doesn't have to be the diameter. Absolutely not. Let me show you what I mean. Okay, so in this case here, look, that is not a diameter. Okay, it could be a diameter, but if it were a diameter, not only would the angles in the same segment be equal, but they'd also be 90 degrees. If that's a diameter there, then yes, that angle here will be equal to this angle here. They'll be equal, but also they'll be 90 degrees because they're angles in a semicircle. Okay, bash on. Bash on. Don't let's spend ages talking about one topic, but I hope you feel okay with what we've done. Why did I add the 90 and the 32 together? Let's have a look at that, shall we? I'm looking at this red triangle here. I'll draw it out here. It goes like this. It goes from B to C and down to D. Right? This angle here in the corner is the target angle. This angle is 28. Now, what is that angle there? Answer, it's here, and it's 32 plus 90. So you could say that that angle is 122, and then you can do 180 minus 28 minus 122. Okay, I hope that makes sense. Okay, I'm not going to skip back, but you have got the answers in the chat. Okay, and it's 30 because it's 180 in the triangle. Take away the 2 angles that I know. You know it's 32 plus 90 because this green angle here is 90 because it's an angle in a semicircle. And you found that that angle is 32 because it's equal to this one here. Okay, let's move on, everybody. Let's move on. You might want to put yourself on mute if you're currently chatting. Just check you're on mute. So we've got 5 and 6. 2 more circle theorems. Before we move on, we've got some differentiation in question 7 because that hasn't come up. And we expect it to come up at least once on the 2 papers. So it hasn't come up, so we're thinking it's going to come up. Well, we'll do our best. I've actually got until 5 to 8 this evening, but of course that doesn't mean that you have. Right. We have got in this diagram here, I know that that's 90 because it's the angle between a tangent and the radius. I know that this angle here is the 3rd angle in a triangle. So I've got 90 and 48. So this angle here must be 42. And I know that therefore this angle is 138. Okay, so that was just angles in a triangle really so far. Now look at this. Here's the circle. Here is the line that goes down to the middle, and then it goes across to D, and I know that's 138. And the angle which is my target here, this one, is this angle here. And look at that. 138 is the angle at the center, and this one is the angle at the circumference. So that will be half of 138. 138 divided by 2, 69. Okay, move on, move on. The 138, Martha, it came from 180 minus 42 because there was 180 on the straight line. And if you have a look at this here, that is a straight line. Okay. Now, if you get an intersecting chord theorem question, then really the best thing to do, if you have the chords intersecting in the center, or if you have them intersecting outside the circle, which is the example we're looking at, make sure you call chords A, B, C, D. They're already called A, B, C, D in this example. Look, A, B, and C and D. And do this. A, B, C, D equals in the middle. And now write P, 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 and that is your intersecting chord theorem. So now I can simply fill in what I know. A to P is 30, BP is 14, C to P is 12, and D to P is that one there. D to P, sorry, is unknown. There we go. So 30 times 14. Do that on my calculator. Gives me 420 equals 12 times dp. So dp is 420 divided by 12, 35. So all of this length from D to P is 35. So therefore DC is 35 minus 12, which is 23. So now is a bit late to start learning the intersecting chord theorem, but that is how it works. Now we're going to have to race on to some differentiation. We've got some functions, we've got some similarity, we've got some hard sequence questions. Okay, now all of these are at the harder end of grades 7, 8, and 9. There aren't many questions here which are easy, and you will find that lots of the paper is easier than these. Right, now differentiation. Differentiating itself is quite an automatic process, and with any luck, 4 times 3 is 12, x squared minus plus 2 times 1 is 2, minus 20. With any luck, you're quite used to differentiating, and we can just differentiate there. Now, in this question, We're asked to find the x-coordinates of the points on the curve where the gradient is 4. Now this, the differential, is the gradient function. So I want to know what x's make that equal to 4. So I'm going to be solving this equation. What x's make the gradient function equal to 4? I'm now setting it equal to 0. And now I'm going to divide everything by 2, I think, to make it easier. Now, if you've got a fancy calculator, you can just enter your values of a, b, and c and get the solutions. If you can see how to factorize it, then that's great. And if neither of those options work for you, then you can use the formula, x equals minus b plus or minus, and so on. I've been able to factorize that, so I get the answers x equals 4 over 3 or minus 3 over 2. And in this question, you're only asked to find the x-coordinates of the points. So we've done it, we've finished the question. If it had asked us for the coordinates of the points, we'd have to take those x-coordinates and substitute them back into the original equation. But in this case, we don't have to do that. I can see some questions in the chat about that one, and there's also a couple of questions about how I differentiate it. So I'm going to go back and look at the differentiation, and then I'll move on. So when you differentiate, we're differentiating this. 4x cubed minus x squared minus 20x. Now, you take the coefficient of the x, multiply it by the coefficient. Sorry, you take the power of the x, multiply it by the coefficient. 3 fours are 12, and then it's not x to the 3 anymore. You subtract 1 from the power. It's just a method. Now, this here is minus 1x squared. So it's 2 times 1 is 2, and it's not going to be x to the power of 2 anymore. It's just x to the power 1. So just x. And here, you've got minus 20x. That is x to the power 1. So it's 1 times 20 is 20, and then you get x to the 0. X to the 0 is just 1, so you can ignore that. So that is how you differentiate. Okay? And now, have I made a mistake? Let's have a look. No, that looks all right. So now I'm solving the equation here. That's the gradient. And I want to know what values of x make the gradient equal to 4. So I'm solving the equation. 12x squared plus 2x minus 20 equals 4. And then I've subtracted 4 from both sides. So now it's 12x squared plus 2x minus 24 equals 0. So I've set it equal to 0. So now I'm ready to, look at that. I've made a mistake here. That should say minus 12, shouldn't it? And so now I divide by 2 here, and that makes it easier to factorize. Okay. All right. I'm going to move on to question 8, which again is differentiation, but this time using differentiation to deal with displacement, which is like a bit like distance, velocity, and acceleration. Okay, thank you for finding my mistake in the chat, and you were quite right. Question 8 coming up. Right, we've got a particle P, and its displacement is 4t squared plus 125 over t. Now, we're not going to be able to differentiate it terribly easily in that form. We need to write this as 125 t to the power of minus 1. And now we can use differentiation. Remember, S differentiated goes to V, differentiated goes to A. So the displacement is that. I've dealt with that. The velocity of P is V. Okay, fine. Well, let's work out an expression for V. So I'm going to differentiate this expression for the displacement. 4 times 2 is 8. Knock 1 off the power. Now, minus 1 times plus 125 is minus 125 t to the power of minus 2. So that is an expression for the velocity. 8t minus, and I'm going to write this as 125 over t squared now. We want to know the time when the velocity is 0. So we're going to solve this equation. What time makes the velocity equal to 0? Well, to solve that equation, I'm going to add minus 125 over t squared to both sides. And now I'll multiply both sides by t squared. So I'm going to get t cubed equals 125 over 8. So that means that t is the cube root of that, 5 over 2. So that is the time at which the velocity is 0. The velocity is 0 after 2.5 seconds. And the question is, what is the distance at that point? So it's asking me, what is the displacement? Remember, that's given by this formula. What is the displacement when t is 2.5, when t is 5 over 2? So what I'm going to do is I'm going to substitute t equals 5 over 2 into this displacement formula. This is a complicated question. I'm going to stick that in my calculator and get the answer for S, which for me is 75. The displacement, you can think about that as distance for the moment, Tiffany, okay? If you're in year 12, it would be essential that we understood about what exactly displacement was. But for now, think about it as distance, speed, and acceleration, okay? Now, you got the answer as 2.5, but the question wasn't saying at what time is the velocity 0. The question was asking you what the distance was at that time. So you had to go ahead and use your 2.5 to work out what the velocity was. How is t 5 over 2 of t cubed is that? Well, let me show you. So you've got t cubed is 125 over 8. Stick that in your calculator and cube root it, and you will get 5 over 2. Okay, because the cube root of 125 is 5, and the cube root of 8 is 2. Right, let's move on. Let's move on and pick up the marks, if only at the beginning of these harder questions. Now, I'm hoping that everybody is happy with functions. You've got to work out fg of 2, and then you've got to work out an inverse function. I've deliberately chosen one with not an easy part 2. There you are. I've gone back for whoever wanted me to go back. If I was going for a grade 8, grade 9, a top mark, I would be working through these questions we're looking at today, and then I would be working through other questions which appear at the end of each paper. I'll get on to question 9 quite soon, so why not bash on with question 10 until I get on to question 9. Now, when you do a composite function like this, I imagine that everybody's quite happy to work out g of 2. We know that g of x is 7x minus 6. So g of 2 will be 7 times 2 minus 6. Well, that equals 8. Now, when it asks you for this, fg of 2, it means get g of 2, I've just done that, and then put the answer to g of 2 through the f. It wants you to f g of 2. So I'm just going to do this here where I've got some room. So f g of 2. Well, g of 2 is 8. So really, we're just being asked to f 8. So it's going to be 5 times 8 squared minus 10 times 8 plus 7. And you can simply put that into your calculator. Okay, so when it's a composite function like that, work out g of 2 first, and then f your answer. And so into here, I get 247. And next, you're being told that f of x is 5x squared minus 10x plus 7, where x is greater than or equal to 1, and you're being asked for the inverse function. My starting point would be to write that as y equals 5x squared minus 10x plus 7, and now make x the subject. Okay. Right, now in order to make x the subject, you're absolutely right in the chat, you will need to complete the square here. Now this is quite complex, okay? If you haven't done this before, you're not going to pick it up tonight. But if you have done it before, you might pick up where you might have made an error tonight, or you might pick up a first step. Right, I'm completing the square on the right-hand side. I've got 5x squared, so I only want to deal with 1x squared. So I'm going to take the 5 out. And now I've just got x squared minus 2x. So 5, open a square bracket. I'm now going to complete the square on x squared minus 2x. Here we go. It's going to be x minus 1 squared minus 1. Copy down the plus 7. Now I'm going to multiply out the bracket. 5 lots of x minus 1 squared minus 5 plus 7. Now I'm going to tidy up the right-hand side. Okay, I'm just doing one thing at a time because I want to get all the marks I can. Now we're going to make x the subject. So that means that what I'm going to do is I'm going to swap it over because I find it much easier to work if the x is on the left-hand side. Right, minus 2 from both sides. Oops, my mistake. Minus 2 from both sides. Y minus 2. Now divide both sides by 5. X minus 1 squared equals y minus 2 over 5. Look how I'm doing each step one at a time because I'm desperately trying not to make a mistake with my algebra. Now I've square rooted both sides, and I'm going to remember that there are 2 answers to a square root. And now I'm going to add 1 to both sides. Right, I've made x the subject. I can breathe a sigh of relief. And now I can write that the inverse function of x will be my expression, but with x in it instead of y. Now that will get you 5 out of 6 marks. What we have forgotten to do is to involve the fact that x has to be greater than or equal to 1. If x has to be greater than or equal to 1, then this expression here must be greater than or equal to 1. So it can't possibly be 1 minus something. It can only be 1 plus the square root of x plus 2 over 5. So the correct answer is 1 plus the square root of x minus 2 over 5. Okay, I'll leave that on the screen there for you. No, it wouldn't, Martha. That would be fine. Louis, I'm not sure, but if you get the same as me, you're fine. But if you don't, you're not. Okay? Sorry to be so black and white. Now, number 10 is a similarity question. So if you know how I use my table, then that will help you with that one. If you don't, have a go and then move on to 11 and 12. Now, 11 and 12 are both sequence questions. And I put those in because we haven't had a hard sequence question yet. And one seems to come up every year. Yeah, I would do LAV down the left-hand side of my table, Anna. Linear, area, and volume. Well, I can give you a hint for question 11. For question 11, you're going to want to be using this formula, which you're given on the formula sheet. And then substitute in what you know and see what happens. Now, I've deliberately chosen not very nice sequence questions, okay? Because I felt we should probably practice not very nice ones. And then with any luck, tomorrow, it'll be easy. Right, I'm going to have a look at question 10 now. I've got A, B, and linear, area, volume. Let's fill in what we know. Vase 10 has a height of 50. Sorry, vase A has a height of 10. Vase B has a height of 15. These are linear measurements, 10 and 15. Well, look at that. I can already work out that the linear scale factor is 3/2. 15 divided by 10. Okay, now, this is not an easy one. Normally, in these questions, they wouldn't say the difference between something and something is whatever. They would just say something like, the volume of this one is 25. What is the volume of B? Something like that. Okay. Or they might say the area of B is, I don't know, 56. What is the area of A? And get you to use the scale factors. This question is more difficult. We are told that the difference between what I'll call VA and what I'll call VB, we're told the difference between those two is 1197. Now, we know the volume scale factor because the linear scale factor is 3/2. So the volume scale factor is 3/2 cubed. Now, you could do that on your calculator if you want to, but I know that 3 cubed is 27. And I know that 2 cubed is 8. So I know the volume scale factor is 27/8. And so if I call the volume of A VA, then this one here is 27/8 times VA. Wait a minute. It tells me the difference between those two volumes is equal to 1197. That means that the larger volume, which is 27/8 VA, minus the smaller volume, VA, is equal to 1197. And there is an equation you can solve to find VA. Okay? You can solve this equation in lots of different ways. If it was me, I'd multiply everything by 8 to give me 27 VA minus 8 VA equals whatever 1197 times 8 is. Let's have a look at that. 1197 times 8, 9576. And now on the left, I've got 19 VA equals 9576. And I'll divide by 19. So I get the volume of A is 504. And what does it ask me for in the question? It asks me for the volume of A. There you go, I've done it. Be careful, always circle back to the question because it might have said, what's the volume of B? Okay, and that is that question solved. Okay. Right, there's lots of discussion going on about one question or other. I'll send you the recording of this session as soon as it becomes available, and with any luck, then you can go back and see if I got it right or got it wrong. Okay. All right. I can see some of you are obviously here in the past because you're used to using LAV in that table. Okay. Right. Now, these are two not nice sequence questions, and I have not included a sequence question where you have to find the sum of the terms from the 50th to the 100th. I did that the other night. Remember, that would be the sum of the 100th, sum all the way up to the 100th term minus the sum up to the 49th term, not the 50th term. We did that the other night. But that could easily be on there. But I've chosen two slightly more difficult sequence questions because I thought that that was probably a good idea. So that's good, Anna. I'm pleased. So we have got question 11 and question 12 on sequences, and then we are moving on to proportion, proportion, bounds, bounds, and a bit of area and volume. And I think we're doing more or less okay on time. I'm going to be quiet for 5 minutes so you guys can do some work. That's the right formula, yes, Louis. The N stands for the number of terms. So we've got, if you were doing the sum of the first 100 terms, then N would be 100. A is the first letter of the alphabet, so that's the first term in the sequence, and D is the difference from one term to the next. Okay. Right, here are the first four terms in an arithmetic sequence. I can already see that A equals 3, the first term in the sequence, and D equals 4, because the difference between each term is 4. Now, I know that my formula is the sum of the first n terms. Oh, wait a minute. It tells me the sum of the first n terms. So my formula is that the sum of the first n terms is n over 2. I don't know what n is. I don't know how many terms we're dealing with here. Okay, it's n over 2 times twice the first term, so that's 2 times 3, plus n minus 1 times the difference. So that is the equation which I have to solve to find out how many terms there are in this sequence. So if it were me, I would multiply both sides by 2, because that's going to get rid of that 2 on the bottom of the n. So I get 14520 equals n times, now 2 times 3 is 6, plus 4 times that bracket. 14520 equals n times 6 plus 4n minus 4. I've just multiplied out that bracket. 14520 equals n times 2 plus 4n. Right. Or 14520 equals 2n plus 4n squared. Right, this is a quadratic equation, isn't it? I'm going to have my 4n squared plus 2n here, minus 1450 for minus 14520 from both sides. That's the equation I'm trying to solve. And this will tell me how many terms there are in the sequence. Now, if I was solving that, I would probably divide everything by 2, 2n squared plus n minus 7, oh, what is that? 7260 equals 0. And now I'd either try and factorize that, or I'd use the formula, or I'd use my fancy calculator. Now, the two answers are n equals 60 or n equals minus 121 over 2. That's how many terms there are in this sequence, right? Well, clearly there can't be a negative number of terms. So n is 60. Now let's circle back to the question and see what it's asking us. Here are the first 4 terms in an arithmetic sequence. The last term of the sequence is x. The sum of the terms of the sequence is find the value of x. It's asking me to find the value of the last term in the sequence. Now, I've worked out that there are 60 terms in the sequence, but that doesn't mean that that the last term is 60. That means that I've got to do this sequence all the way up to the 60th term. And I'm being asked, what is the 60th term of that sequence? So to work that out, I better work out the nth term. Well, the nth term here is 4n minus 1, because it's a difference of 4. It's 1 beneath the 4 times table. And it wants to know the value of the 60th term. So the final answer to that question is 239 is the last term in that sequence of 60 terms. Okay? And that is that question gone through. Okay. You don't have to know the equation. No, Maisie, it's on the formula sheet. Okay, and Effie, when you think what the terms mean, you know D equals difference because it begins with a D. Okay, A is the first letter of the alphabet, so just remember that's the first term of the sequence. Okay, and what was the other one? N is the number of terms in the sequence. Now you don't know the T equation, right? Now you do need to know this. Yes, you need to know how to write down a formula for the nth term of a sequence. This one goes up in 4s, so it's 4n, and then you have to think about whether it's 4n and what the correction is. In this case, it's 4n minus 1. Okay, you do have to be able to do that yourself, yes. Right. In a moment, I'm going to do question 12. Oh, I don't know. I've never seen that formula, Mohammed. I've never used that formula. Okay. So you've got me there. Okay, I'll have to look that up. Good. Well, if you got the right answer, then you're fine, Mohammed. Okay. Yes, I knew that formula, Raphael. Anyway, right. I did the summation formula, but I got it wrong. How do I know when to use quadratic? Well, the thing is, in that question there, I didn't know it was going to end up as a quadratic equation. It just did. Okay? All right. It just did work out to be a quadratic because I got that and I solved it and I ended up with what was a quadratic equation. Okay? So then I know how to solve quadratic equations. So I just cracked on with it. Okay. It sounds like lots of you are using the same method, which is different to mine, but it's absolutely fine. Okay. Right. Let's have a look at this one. Okay. The sum of the first 10 terms in an arithmetic sequence, so S10, the sum of the first 10 terms, is equal to 4 times the sum of the first 5 terms of the same sequence. Now, I know it says the 8, I know there's more information, but I'm going to stick with this bit for a moment. Okay? Now, oh, it does say the sum of the first 10 terms. Right, let's have a look. So the sum of the first 10 terms is going to be 10 over 2 times 2a, I don't know what the first term of the sequence is, plus, now n minus 1, so that's going to be 9 times the difference. I'm just using this formula, everybody, n over 2 times 2a plus n minus 1d, but I'm doing the n minus 1 in my head, okay? Now, that is the left-hand side. And that equals 4 times the sum of the first 5 terms. So the sum of the first 5 terms, 5 over 2, times twice the first term plus n minus 1. So that's 5 minus 1 is 4. There we go. Right, 10 over 2 is 5, right? 5 times 2a plus 9d equals, now 4 times 5 over 2 is 10. So that's 10 times 2a plus 44d. So that's going to be 10a plus 45d equals 20a plus 40d. I don't think I can go any further at the moment. Okay. I don't think I've made a mistake, but we'll soon find out. Right. I've got A's and D's. It's a bit annoying to have both, isn't it? Okay. Oh, I suppose I could, if I wanted to, minus 10a from both sides and minus 40d from both sides. Look at that. That's quite neat. Okay. Right. Now, I'm going to use this piece of information now. The 8th term of the series is 45. Now, the 8th term is the first term plus 7 differences. It would be the first term plus 7 jumps. And that equals 45. And now you see I've got this equation and this equation. So I can make sure I've got 2 equations with 2 unknowns, so I think I can make some progress now. Lots of ways of doing this. I'm going to take this green equation at the top and make A the subject. And now I'm going to substitute that in to my equation at the bottom. So it's going to be 5d equals 10 times a. That's that, isn't it? 10 times 45 minus 7d. And now I've got an equation just with d's. So I'm feeling quite good about that. Add 70d to both sides. So 75d equals 450. Divide both sides by 75. And d equals 6. Excellent. What's the question? Typically, look, it's find the first term. It wasn't find the differences. So now I know that d is 6. And up here, I knew that a is 45 minus 7d. So that's going to be 45 minus 7 times d, 7 times 6. So 45 minus 42. So that gives me a is 3. And that is my solution. And that must be the first time in a long time that I've been able to say 45 minus 7 times 6 and not had somebody say 6, 7. But then I haven't looked in the chat yet. Okay, that's number 12. Are you happy, Tiffany, with where the 7D comes from? And yes, Anna, you could do that. Waiting to hear from you, Tiffany. Meanwhile, everybody else, you can crack on with what you're doing. Oh, brilliant. Well done. Good. Okay. Right. Okay, we seem to be doing all right. I've got another half an hour or so. It doesn't mean you have to stay, okay? But you are very welcome to stay. I hope you're cracking on with something. We've got a relatively straightforward proportion question and a more difficult proportion question. We've got a relatively straightforward bounds question and a more difficult bounds question. And then we've got these two to do. And then, to be honest, I think the last page we may not have time for, but they were kind of bonus questions anyway. Okay. So, proportion. Now, whenever I have a proportion question, this is my kind of mantra. I always say to myself, fish sign equals find K, use K. So when it says T is directly proportional to the cube of R, I write T fish sign R cubed. T is directly proportional to the cube of R. And now I do the equals, T equals K R cubed. So I've done fish sign and I've done equals. And now I'm going to find K. I'm going to find K because I've been told a pair of values that work. So I know that T is 21.76, so I can put T in 21.76 instead of T is K times 4 cubed. And now I can solve this equation to find K. In this case, K is 21.76 divided by 64, 0.34. So fish sign equals find K, done that, right, use K. What that means is write the formula again. It was T equals KR cubed, so now I know it's T equals 0.34 R cubed. Fish sign equals find K, use K, done that. And that is my formula for T in terms of R. All right. And now, because this is a relatively straightforward question, mind you, they are generally straightforward. It says work out the value of T when R equals 6. And here's my formula, so I can just substitute in R is 6 and stick that in my calculator. Okay, and I got the answer 73.44. Yep, you're about to do a more complex one, yes. Okay, I don't think indirect proportion really qualifies as, on its own qualifies as more complex, okay? But this one does because it has two proportions in it, question 14. Also, look at this one very quickly, please. They could make this one slightly more complex. Part C, for instance, they could say to you, work out the value of R when T equals something. I don't know, T equals 100, and just get you to use the formula the other way round and find R. Okay? So just look out, make sure you substitute in the right values for the right letters. Question 14 coming up in a moment. What I'd say, Mohammed, is that I've managed that with some of the topics, or most of them perhaps, but I thought if I just did 20 questions from the the last question on the paper, then actually everyone would go into their exam tomorrow feeling that they were rubbish, which would be really unnecessary because, of course, there's only one end question on each paper. Okay. So, for instance, the sequence questions, they are very, they're at the tough end. This proportion question is at the tough end. Okay. All right. Okay. Look at this one. The circle theorems question, that intersecting chord theorem. Yeah, these volumes and surface area questions, they're tough coming up. Right, let me do this one. Y is inversely proportional to root x. Y equals k root x. X, oh, well, sorry, I suppose what I should have done really is done my fish sign thing. So y fish sign, oh, I got it wrong anyway, just as well I started again. Y is inversely proportional to root x. Y fish sign 1 over root x. Y equals k over root x. Okay, now x is directly proportional to t cubed. X fish sign t cubed. X equals, I can't use k again. Okay, so I'll use p. X equals p t cubed. Now I can take this and put it in here instead of x. So I'm going to get y equals k over the square root of pt cubed. Right, fine. Now, I've got two unknowns here, k and root, and k and p. The way out of this now is to say, okay, I appreciate it's a complex equation, but I'm just going to say y equals c over t root t cubed. Just do that. Okay, why do we need to fuss with k's and p's? Forget it, just put a third letter there. And now we're going to find c by using the values that we're told. T is 25. Sorry, I beg your pardon. Y equals c over t cubed. So 8 equals c over the square root of 25 cubed. So c will be 8 times the square root of 25 cubed. Stick that in your calculator and you get c is 1,000. And now I know the formula is y equals 1,000 over the square root of t cubed. And that is the formula that links y and t. So now I can get on with the question. And the question is, find the exact value of t when y is 27. So 27 equals 1,000 over the square root of t cubed. Multiply both sides by the square root of t cubed. 27 times the square root of t cubed equals 1,000. Divide both sides by 27. The square root of t cubed equals 1,000 over 27. Now, on your calculator, or put it this way, square both sides. Okay. And now t is the cube root of that. So you can just put that in your calculator, really. The cube root of 1,000 over 27 squared. Stick that in your calculator and you'll get the answer, which is 100 over 9. I did tell you proportion questions could become more complex, and that's an example. Now, we didn't really get rid of K and P. We just said, forget it. I'm just going to call it C instead. Okay. And yes, you name it C. That's right, Louis. Okay. All right. Now, somebody's asking about the last questions at the end of the paper. What's the strategy? What do you do? What you do is translate what they've given you into maths. That's a good idea. Take a first step is always my secret. Sometimes the first step is draw a diagram. Okay. All right, you can just leave it as well, yes. Sometimes the first step is to draw a diagram. Sometimes the first step is to work out anything you can work out. Okay. All right. Let's have a look at that one. Right. Okay, so why did I square it and where's the p gone? Let's have a look. I squared it because on the left-hand side here, I had the square root of t cubed. So I squared both sides to get rid of that square root. And then did somebody ask where the p had gone? Ah, yes. Did you ask where the p had gone? Let me have a look. But where's the p gone in the final formula, the last one in black? Well, what we've got here is we've got y is here. Look at this one. We've got y equals k over the square root of p square root of t cubed. So I just decided that I couldn't be doing with this. I'd just call it c. Okay? And that meant that I had a formula which was easier to work out that c. You could use any letter, yes. I get the answer, but in the steps I didn't mention square. Well, no, you don't have to show what you're doing, entirely. You can do several steps at once on your calculator. Okay, so that's absolutely fine. All right. Okay. Right, now bounds. Question 15 is an example of a more straightforward bounds question than question 16, in my view. Please, when you get a bounds question, just don't even read the thing to start with. Just work out the upper and lower bound of each of your letters, of each of your variables. Okay? So I'm writing c equals 8. So I'm writing c equals 8. It's correct to the nearest whole number. So I'm writing 8.5, 7.5. I haven't even read the question yet. F equals 6.62. Correct to 2 places. 6.625. 6.615. I haven't read the question, but I'm already scoring marks and I'm laying down some stuff which will help me get the question right. And because I'm only thinking about what I'm doing, I'm less likely to make a mistake in working out those bounds. So I have started the question like that. Okay. Now I'll read the question. It gives me a formula for G. And then it says work out the lower bound for G. Write down the formula. Now we need the lowest possible G. So only now are we going to think about how we get the lowest possible G. Okay? Right. How do we get the lowest possible G? Well, if I want the lowest possible G, then I'm going to do the lowest possible G here. Now, that means I want the G as a fraction, right? So I want the top of the fraction to be as low as possible, and I want the bottom of the fraction to be as high as possible. That means I want the highest possible F and the lowest possible H, because then the difference between the two F's and the three H's will be as high as possible. And only now do I write in each version of the numbers. So I have done this. So each time I've only been thinking about one thing at a time. Okay. And each time I've been thinking of that thing, I've been writing it down. All right. And that gives me on my calculator 0.7653 and so on. And it wants the answer to 3 decimal places. So I'm going to write my answer to 3 decimal places. Okay. Now there's been lots of chat. I can't read the chat and write on the screen at the same time. So I'm worried I got something wrong if you're all chatting, but no. There was a bounds question in paper one, but it was so easy, okay, that I'm expecting them to ask a different one. Okay? Right. Question 16 coming up in a minute. Now, by the way, you won't be surprised to hear that the first thing I'm going to do is write my upper and lower bound for V, U, and T. I'm not even going to read the question. Okay? There wasn't really a volume question in paper one. That was more a 3D trig question. Okay? So, yes, I know it involved volume, but we're talking about pyramids and all the rest of it now. Okay? Right. I'm not even going to read the question. I'm just going to write down my bounds. V 4.45.23, so 45.235, 45.225. U 5.12, so 5.125, 5.115. T 8.5, so 8.55 and 8.45. Right, I haven't read the question yet, but I'm pretty sure I won't have messed that up because I was concentrating only on it. By considering bounds, work out the value of A to a suitable degree of accuracy. That means that I'm going to need to, on one side of my page, work out the lowest possible A, and on the other side of my page, I'm going to work out the highest possible A. And then I'm going to deal with how to answer the question. So on this side, I'm going to do the lowest A. So I'm going to want the lowest A. So I want the lowest number on the top. So I want the lowest V and the highest U, because then one minus the other will be as low as possible. And if I want the lowest A, then I want to divide by the largest number possible. Now, over here on the right-hand side, I'm going to do the highest A. So I'm going to want the highest top. So highest V minus least U. And I want the highest possible A, so I'll divide by the smallest possible number. And then have a look. Do you see how all the arrows on the right are the reverse of the arrows on the left? Right, here we go. Let's do the left. The lowest possible A. Right, lowest V. 45.225 minus highest U, 5.125. All over the highest possible T, 8.55. Stick that in your calculator and work it out, but maybe not yet. Let's do the highest A. The highest A is the highest V, 45.235, minus the lowest U, 5.115, all over the lowest T, 8.45. Now look, you should have both versions of each of your numbers. If you've repeated one, you've made a mess of it. So go back and start again. Okay. Now, if I put the left-hand side into my calculator, the lowest possible A, I get 4.690058 and so on. And my highest possible A, I get 4.74792 and so on. So what can I say about A? For instance, can I say what it is to the nearest whole number? I definitely can, because this one to the nearest whole number is 5, and so's that one. So whatever A is, wherever it lies between the lowest and the highest versions, it's always 5 to the nearest whole number. Can I say what it is to one decimal place? I definitely can, because the left-hand side to one decimal place is 4.7, and the right-hand side to one decimal place is also 4.7. Can I say what it is to two decimal places? No, because this one to two decimal places is different to that one. So I can say with certainty that A is 4.7, and then I would probably say to two significant figures. I imagine one decimal place would be okay. All right. And that is question 16 done. Okay. Right. I don't think there'll be more 3D trig. No. Circle theorems. No, do you mind going through question 17? I'm doing my best now. Omar, could you say to two decimal places also? I don't think you could, Omar, because the trouble is that if I go to two decimal places, this one is 4.69 and this one is 4.75. So they're different, aren't they? So I can't say what it is to two decimal places. Okay? Right. Maisie, you're distracting us with grey boundary talk. It doesn't matter. We just need to get all the marks we can. Right. Questions 17 and 18 and 19 and 20. Right. Okay. Right. Oh, Maisie. And look, will you stop the grade boundary talk? Okay. Right. What do you put as the reasoning for question 16? I don't think you have to put any reasoning. You just have to give your answer. Okay. Show you're working clearly. Oh, and give a reason for your answer. Okay, I take it back. Thank you for your question. What I would do is I would probably do this. I'd probably say I'd probably say a lower bound equals a upper bound to two sig figs. Or I would say something like, perhaps I'd show this. Look, I'd show this stuff. I'd go 5, and that one was 5. I'd go 4.7 and show that one was 4.7. And then I'd go 4.69 and show this one is 4.75. And therefore they're different. Something like that. Okay? All right. Question 17. Right. Okay. Right, I'm going to have to ignore some of the chats now, otherwise we're not going to carry on. Now, you don't need to know these formulas, but you've got them on the formula sheet. Now, I look at this question here, and I'm going to help you out as if you read it and you thought, I don't know what on earth to do. What am I supposed to do with this question? It says the diagram shows a sphere of diameter x and a pyramid with a horizontal rectangular base. Look at the diagrams. Okay, sphere, pyramid. Notice this is different. Right, the vertex A of the pyramid is vertically above the center O. Yes, that's how it looks. So I'm not, it looks like that on the diagram. BC is X, that's marked on the diagram. CD is 2X, that's marked on the diagram. AO is 5X, that's marked on the diagram. But I'm going through this process so that I take note of what I'm being told. The volume of the sphere is 288 pi. Wait a minute. Doesn't that mean I can find X? Because I know the volume of a sphere is 4/3 pi r cubed, and I know that equals 288 pi. Well, that means I can find r, doesn't it? Divide both sides by pi, multiply both sides by 3 and divide both sides by 4. The radius of that sphere is 6. So in that case, x, which is the diameter of the sphere, is 12. Right, I've already got 2 marks, I think. And now I'm going to call that 12. I'm going to call that 24, and 5 12s are 60. And now the question just boils down to calculating the total surface area of that pyramid. Now, I am not saying that it's easy, but we've boiled down the question to a simpler question than it was. The surface area of that pyramid. Okay, I know there's a base, and I know the base measures 12 by 24. So I've already found I'm feeling good about myself. Now, I've got to find the area of those 4 triangular faces. I'm going to concentrate on this face. Watch. A to C to D. I'm going to concentrate on that face to start with. It's a triangle. Okay, here it is. I'll draw it out here. It's a triangle. Okay, and it measures 24. That's supposed to be an isosceles. That's A, that's D, that's C. I wish I knew the height, because if I did, I could find its area, base times height over 2. Now that green line, look, it appears here, right? That is the green line. And I could find that green line if I use this black triangle, which I'm marking on the screen here. That black triangle has my green line as its hypotenuse. And the green line happens to be the height of the triangle that I'm dealing with. Right, well, that measures 6 because it's half of the 12. That measures 60. I can do Pythagoras to find the green line. Okay, right, calculator. Square root of 60 squared plus 6 squared equals. So that green line is 6 root 101. Okay, now I could find the area of this triangle. The area of the triangle is the base times the height divided by 2. Okay, right. Oh, by the way, this face is the same area as the one opposite it, right? So I'm doing okay. I've only really got to find the face of the triangle, the area of the triangle on the front of the shape now. Let's draw that. So I hope you guys chatting aren't putting yourself off. I hope that if you are watching this, you're able to ignore the chat. I'm finding the area of the triangle on the front there. It's 12, and I wish I knew the green height here. Okay, and I can do that because I can go from, I'm going to do this in a thick black line. I'm going to go from A down to O. Oh, this is going to be a horrid diagram there. And then here's my green. So I've got the black A down to O, the black across there, and then I've got the green line here. Now that's 12, that's 60, use Pythagoras. Square root of 60 squared plus 12 squared equals, the height is 12 root 26. Sorry, that's the hypotenuse, which is the height of that one. So now I think I'm on a roll because I've got the base, 12 times 24. I've got the area of my first triangle, 24 times 6 times root 101 over 2. I've got 2 of those, so times by 2. I don't know why I bothered to divide by 2 really, but never mind. And now I've got the area of my second triangle, 12, which is the base, times the height, divided by 2, and then of course I've got 2 of them. And so now if I add together the base, the area of those 2 triangles, and the area of those 2 triangles, I'll get the surface area of the whole pyramid. Okay? Right, let's have a look at the chat. I love this up. Good, good, good. Why, wait a minute, why is O to 2412? Oh, thank you. Anna's answered that, has she? Good, excellent. Why did we divide by 2? Divide what by 2? Oh, well, because I was finding the area of a triangle, so I did base times height divided by 2. But then I realized I had 2 triangles, so then I doubled it again. Okay? Why did I use 4 over 3? Because the formula for the volume of a sphere is 4 over 3 pi r cubed. Okay? All right. The base times height over 2 works. That's the area of any triangle, not just isosceles triangles. Okay, base times height over 2 is the area of any triangle. Okay, right. Do we get the sphere formula? Yes, you do, Martha. You get formulas for the volume of a sphere, surface area of a sphere, volume of a cone, all sorts. Okay. All right. Okay. Are we feeling brave enough to move on? Isn't this? No, yes, but it was a cube root, Izzy, because I had r cubed equals 216. Okay, so what's the answer? Good question. Got it here somewhere. Question 17. The answer I got is 2469. Okay. 2469 to the nearest square centimetre, 2469. Okay, right. Are we ready for spheres in question 18? Okay, this is going to have to be my last one because I've got another class at 8 o'clock and it's 20 to 8. Right. I like this question though. Now, first steps. First steps. The radius of the hemisphere is 2x. So let's label that 2x. The radius of the base of the cone is 5x. Let's label that. It's not very easy to label, is it really? I'll go to there. 5x. The vertical height of the cone, that's this length here, isn't it? Is 6x. Right. A solid shape is made by removing a hemisphere, shown shaded, from a cone. The radius, the vertical height. I've written all those on. The volume of the solid shape is 6948 pi. Okay, the volume of the solid shape. Well, the volume of the solid shape is the volume of the cone minus the volume of the hemisphere. Now, perhaps I've got an advantage over you because I've got the formula sheets here. But the volume of a cone is a third pi r squared h. That's the cone, right? And I'm going to minus the volume of the hemisphere. Now, the volume of a whole sphere is 4/3 pi r cubed. So the volume of a hemisphere is just 2/3 pi r cubed. And that is the hemisphere. Okay, let's fill in what we know. Looking at the cone, it's a third times pi. Now, what's the radius of the cone? 2x, but be careful, it's 2x squared. Like that, make sure that you're going to remember to square the 2 times the h, which is 6x. That's the volume of the cone. No, it's not. What a lot of nonsense. I got the wrong radius, didn't I? The radius of the cone is 5x, so it should be 5x squared. Is that looking better? I hope. Minus the volume of the hemisphere, 2/3 times pi times the radius of the hemisphere cubed, 2x all cubed. And I know that equals 6948 pi. Happy, I hope. Let's simplify this. A third pi times 25x squared times 6x minus 2/3 times pi times 8x cubed equals 6948 pi. Right. Oh, I'm going to divide everything by pi. I hate doing, I'm not going to, I was just going to cross everything out, but I'm not going to do that. So I'm going to divide everything by pi, so the pi's have gone. And then on this bit here, I've got a third times 6 times 25. I could stick that in my calculator. It comes down to 50x cubed. So I've got a third times 25 times 6, and then x squared times x, minus 2/3, the pi's gone, times 8x cubed. Well, that is 16/3 x cubed equals 6948. Remember, I've divided by pi. Okay, so now on my calculator, I could just work out what 50 minus 16/3 is. Okay. 50 minus 16/3 on my calculator, that gives me 134/3 x cubed, and that equals 6948. So now I can work out x cubed by multiplying by 3 and then dividing by 134. So x cubed is equal to 155 point something. Cube root it to get x is 5.3780. I'm writing down enough digits so that I don't make a mistake with my rounding. I found x. Now, what was the question? Calculate the total surface area of the solid hemisphere that has been removed. So I'm being asked to work out the total surface area of that. And at least I know what x is now. X is 5.37. So that means that I know the radius of the hemisphere. It's twice x, though, remember? The radius was 2x. So the radius is 10.75611. Okay, I'm just pausing for a minute in case. No, you're not going to fail maths, you great loon. We're looking at a grade 9 question. Okay? All right. Right, here we go. So the area of that circle is pi r squared. So that's the area of the circle. And onto that, we'll have to add the area, the curved, it's like an orange, isn't it? And you've got half the orange skin there. Now, I've got an advantage because I've got the formula sheet in front of me, if I can find it. So I can tell you that the area of a surface area of a hemisphere is 4 pi r cubed. So we've only got a hemisphere here, so it's not going to be 4 pi r cubed, it's going to be twice, 2 times pi r squared. What planet am I on? So that is the surface area of the hemisphere that has been removed. And it works out to be 1090. Okay, now, if you're feeling like whoever it was who said they were going to fail maths, you have to remember a couple of things. Okay, this question we're looking at was a question 23. It was probably the last question on the paper in June 24. Okay, most of us wouldn't expect to get the last question completely correct. Okay, if we can pick up a couple of marks on the final question, then we should be chuffed. Okay, because you can still get a top grade if you lose a couple of marks on the last few questions. And the thing to remember is all of these questions that we've done today, the vast majority of them would appear in the final third of the paper. Okay, and how many questions have we done? Wait a minute. We've done 18 questions. Okay, and let's face it, there aren't 18 questions in the final third of the paper, are there? Okay, so you need to, it's all very well me saying you need to be a bit realistic. Okay, all right, but okay, you will be absolutely fine. And we've been looking at the horrid questions today. Okay, and also we've been looking at grade 7, 8, and 9 topics, but we've also looked at the harder end of the questions on those topics. Okay, right. All that for 5 marks. That's right. So you see, if you got nothing out of 5, then you've only lost 5 marks. You see, it's not like it's, you get the idea. So it's quite nice. It's only 5 marks. Okay. All right. I'm afraid that I have to go now. Okay. At the end of the paper, you should do the Dara technique, Anna. Watch the film. Okay. All right. And Anna, is it the case that if you go in 2 hours, do you tend to finish the paper or at least try everything you want to, or do you tend to run out of time? Okay. I'm going to put the model answer sheet in the chat again. Okay. And what I suggest you do is I suggest that you click on it now and then save a copy, because I'm not going to send you the recording of this meeting for some time because it takes Zoom a while to allow me to access to the recording. So so to be honest, with any luck, you're going to be asleep before the recording's available. Okay, so I think you would be much better off looking at the answer sheet and not waiting for the recording. Okay. Right, here come the answers. I'm just copying the link now from the screen here, and then I'll shove it in the chat. Okay, answers. Can we just have a nobody type anything for a couple of minutes so the answers remain at the bottom of the chat for anybody who wants to find them? Okay. All right. Sorry, what method? Oh, Anna. Here's the Dara method, okay? So write down D-A-R-A. Dara, D for done. You just check you've done every question. You check you haven't turned over a double page. You check you've done the question at the back. And at the top of the paper, it tells you how many questions there are. So you make very sure that you have done all the questions, okay? Next, A. is, have you answered the question? For instance, it might say, what's the well, we had an example here, didn't we? It said, what's X? And it would be easy to write 60 because it was 60 terms. And actually, it was asking you for what the 60th term was. Okay. Or somebody today said, isn't the answer 5/2? And it wasn't. That was the time. And the question was asking for the displacement. Or if the question's asking for a probability, make sure you give a probability. Okay. D for done, A for answered. R, is your answer reasonable? Okay. If it's asking for the height of a door or the radius of a sphere, let's make very sure that your answer is reasonable. And A, just go through the whole paper again and check that whenever it says give your answer to a certain degree of accuracy, you've done that. So what you do is you go through the paper 4 times. The first time you look for D for done. The second time you look for A for, can't remember what it was now. Oh yes, have you answered the question? Then you look through the paper a third time for are your answers reasonable? And then you look through a fourth time to spot the degree of accuracy. Okay. Right. I am going because I've got to go. You've got to go. Go to bed. Okay. All right. Good luck tomorrow. I'm sure it'll go well. Thanks very much for coming tonight. Okay. And have a good rest of the evening. All right. Okay. Right, everybody, I'm going to end the meeting now. So thanks very much for coming. Okay. And I hope that tomorrow goes really well for you. And remember, most of the paper is much easier than the questions we've been doing. Okay. All right. Okay, if you're still here, I'm going to end the meeting. Thanks very much for coming.
Thank you very much.
See you later. Well done.